BSCE illusions. Our topic is resistance in circular pipelines flowing full. A fluid moving through a pipeline is subjected to energy losses from various sources. A continuous resistance is exerted by the pipe walls due to a formation of boundary in which the velocity decreases from the center of the pipe to zero at the boundary. Water flows from a tank through 160 feet of 4 inches diameter pipe and discharges into air. The discharge of water in the pipe is 12 CFS. Assume N equals 0.013 and neglect minor losses. Determine the velocity of flow in the pipe in FPS, the total head loss in the pipe in feet, the pressure at the top of the tank in PSI. The water surface is 10 feet above the center line of the pipe. Given the same diameter of the pipe, which is 4 inches, the length of pipe 1 is 40 feet, pipe 2 is 100 feet, and pipe 3 is 20 feet. As what I have stated earlier, the given is a discharge which stands as Q is 12 feet cubed per second. Convert this to meter cubed per second, then it will be 0.3401 meter cubed per second. The diameter of the pipe is 4 inches, is converted to 0.333 feet, will also be equal to 101.6 millimeters. The friction factor, which is 0.013, and the length, which is 160 feet, that is equal to 48.78 meters. The first thing we need to do is to determine the velocity of flow. In order to find the velocity of flow, we have a formula for our discharge which is equal to area times velocity. Then the velocity can be derived from that formula, which is velocity equals discharge over area. This is equal to 12 divided by pi over 4 times 0.333 feet squared. This is equal to 137.785 feet per second. The second thing we need to determine is the total head loss in the pipe. Since the given is N, we need to use the International System version of Manning's formula, where the head loss is equal to 10.29 square of friction factor, the length, times square of discharge over the diameter raised to 16/3. Now, we need to substitute the given using this formula, where 10.29 times 0.013 squared times 48.78, multiply it by 0.3401 divided by 0.1016 raised to 16/3. The head loss will be equal to 1942.33 meters. Convert it to feet, you will get 6,370.86 feet. Since the elevation is given, make the center line of the pipe as the datum line. The third thing we need to determine is the pressure above the water surface at the elevation head of 10 feet. The formula we are going to use for this is the energy equation at point A minus the head loss will be equal to the energy equation at point B or C. The energy equation at point A, which is equal to the velocity head plus the pressure head plus the elevation head, of A minus the head loss equal to the velocity head at C plus the pressure head of C plus the elevation head of C. Since it is located at the top, the movement of the water will be assumed as zero because it is negligible. We would also assume that the pressure head of C is equal to zero. It will be equal to 0 plus P over unit weight plus 10 minus 6,370.86 is equal to 137.785 squared over 2 times 32.2 plus 0 plus 100. Take note that the use of 32.2 is with regards to the English system of the gravitational force. Now you would get the pressure head of A would be equal to 6,755.65 feet of water. After you would get the pressure head, you would multiply it to the unit weight of water. This will be equal to 421,552.8 psf. Since the required is psi, you would then convert it. So now the pressure would be equal to 2,927.45 psi. There is another way of solving the head loss. This is through using the Manning's formula, where the velocity is equal to 1.49 over the friction factor. Multiply it by the hydraulic radius raised to 2/3 and times its slope, which is raised to 1/2. Given the velocity is equal to 137.785 feet per second, the hydraulic radius that can be solved to d over 4, which is equal to 0.333 over 4, which is equal to 0.08333 feet. The formula of getting the slope is head loss over its length, which is equal to head loss over 160 feet. This is where you would substitute the given through the formula we are using, where V is equal to 137.785 equals 1.49 over 0.013. Multiply it by the hydraulic radius, which is 0.0833 raised to 2/3. S is equal to HL over 160. So we are going to use that, where HL over 160 raised to 1/2. HL will then be 6,356 feet. Now you can review your answer. The velocity of flow, which is equal to 137.785 feet per second. The head loss, which is equal to 6,370.86. The pressure in the tank, which is equal to 2,927.45 psi. The head loss using Manning's formula, which is equal to 6,356 feet. Thank you for listening, and we hope that you have learned something.